Once again, good morning class and welcome back to our class in statics of rigid bodies. And what I've said earlier, we are now on our third module, which is the force system resultants. And for our second topic, we will talk about some principles of moments. And this one is a very important principle for you to be able to easily analyze problems whenever you encounter difficult ones later on. Okay? So in this topic, we will talk about this principle of moment, which is known as the Verignons Theorem. Our main goal for this lesson is to understand the concept of Verignons Theorem and to solve problems applying Varignons Theorem. Varignons Theorem originally was developed by this French mathematician Pierre Varignon. It is one way in making complex moment problems into some simple moment problems. Unsa man inyong nabantayan nga taas sa atong solution when we are solving for the moment? Probably ang lisod lang dito is to apply the trigo when solving for the moment arm, right? Usually sa atong mga solutions kaganiya, those are the tag-as og mga solution. And I'll be giving a problem here. Let's say, for example, I have a force of F here. And this is your moment axis. And this is the only given direction. The question is, how can you determine the moment of this force? As you can recall, we have to have the moment arm. And the moment arm in this case is, kung ato na is diretso, atong moment arm should be the perpendicular distance, which is this one. But the problem is, ang lisod aning pag-solve og moments kay kung ing-ani ang atong distance. We have to compute this distance. And we don't have enough information for us to solve for this D. Because the only given distance probably in this case is only your x. So, how can you solve this kind of problem if only this is your given? You can actually solve it by applying Varignons Theorem. Because Varignons Theorem basically just states that the moment of a force about a point is equal to the sum of the moments of the components of the force about that point. What does that mean? We have this force, and if we are going to establish our x and y components, if we are looking for the components of this force, which is that one and that one, this is your fx and your fy. Then, the sum of the moments of these two forces is just equal to the moment of this force. Okay? So therefore, unsay pasabot ana? Just basically means that F times D is equal to Fx multiplied by the moment arm of Fx, but in this case, 0 man. So ato lang isulti nga y. Okay? But 0 ni diri nga kaysa, but ato lang gibutang nga y para natay value. Plus Fy times x. This is your Fy, and this is your distance x. This is your Fx, and kung naalang tayo perpendicular distance dira, moment arm, that is your y. But in this case, 0 man kay along man na ang atong Fx diri sa atong. Mao lang ni ang pasabot sa atong Verignons Theorem. That the moment of this force F is just equal to the sum of the moments of these two components of the force. Okay? Take note, that is the Verignons Theorem. And that is very applicable whenever you're going to apply it on these, on to apply that concept in this kind of probably lisod ng mga cases. Let's have an example. I have a force of 5 kilonewtons applied to the end of this beam. The problem is, your 5 kilonewtons is not directed perpendicularly to this direction of your beam. It is directed 15 meters from it. And we have to determine the moment of the force 5 kilonewtons. So, if we are going to solve this one using our previous knowledge about moments from the formula force times distance, what we did is we have to make a straight line. The direction of the force. The line where the direction of the force is located. And now, we have to determine asa na magperpendicular, and kung asa na nagperpendicular, that is your moment arm. So in this case, let's say this is your point of moment, this is your moment axis, and let's say that is your perpendicular lines. And therefore, this is your moment arm. This is your moment arm. The problem is, ang ato lang nahibawaan nga angle is your 90 degrees. And how can we solve for your moment arm in this case? Well, we have a given here of 15 degrees. And this 15 degrees is the angle from perpendicular ani to the direction of your force. Probably we can use that. Okay? Kung ato na idiretso dito, we can say that this is your 15 degrees as well. Right? And we knew that this angle here is perpendicular. So therefore, by using this 15 degrees and by using our knowledge that this one is a perpendicular angle, then we can determine this angle. And that angle is basically 90 minus 15 degrees, and that is 75 degrees. So, naratay 75 degrees. We determine this one. And what we are looking for is this one. And ato i-consider ang kani nga triangle. Kani nga triangle. Kani. Okay? Mao na atong focus karon. And we know this is a right triangle. Okay? So we can apply Sohcahtoa. And how can we apply that one? These are your, this is given, this is given, this one is your hypotenuse, and this one is your unknown. And that is angle opposite over hypotenuse. So therefore, your D can be determined as 3 sine of 75 degrees. So therefore, you can solve for D as 2.9. Okay? And this is, again, that is your D. 2.9 meters. And we can now solve for the moment. So therefore, moment about point O is equal to, sige, maghimo tag positive direction, which is clockwise lang. Okay, clockwise. Okay, marag clockwise man yung mahimo ani. So, 5 kilonewtons multiplied by 2.9 meters. There you will get the answer of 14.5 kilonewton meter. And this one is going direction clockwise. So this is your answer. Understood? Well, sayon siya, I think, if kibaw na ka mag-think outside the box, kay nag-think ka outside the lines. Pero, if there are some instances that this is harder, and let's apply the Verignons Theorem in solving this problem. Sige. Remember that the answer is 14.5. 14.5 kilonewton meter that way. One ang answer ha? And instead of applying this one, let's use Varignons Theorem in solving this kind of problem. And let's again establish our x and y axis. So therefore, you have this force, and this is your x component, Fx. And this is your y component, Fy. So, diretso na da. Since doon naman ito ka force, then let's sum these forces. Summation of moments about point O. Let's say that our positive direction is going this way, counterclockwise, is equal to, ato unahon ng Fx. Is our Fx positive or negative? Di ba, maoni ang direction sa atong Fx, and this is your moment arm. This one, this is your moment arm. So, if ato ibutang ang Fx, nya padong ang iyang direction dito, what will it create nga direction? That is clockwise, therefore negative. What is the component of your Fx? Diretso na ta. This is adjacent, unknown, adjacent over hypotenuse. So that is 5 cosine of 45. Diba? Sakto? Then, the moment arm, which is, diba, you have solved for the component of your Fx, and that is adjacent over hypotenuse. This 5 cosine of 45. And now your direction of your x is going that way, and this is your guideline. This is the direction of your force F, and the perpendicular distance is this one. So now you have to determine this one. And this one is basically from this triangle of what you have created. And you know that this angle is 30, so therefore this angle also is 30 degrees. Okay, so therefore, opposite over hypotenuse. This is 3 meters, so 3 meters sine of 30 degrees. Sakto? Sakto. So, mao ni ang atong Fx, and then ang atong d. Let's call this one dy, kay sa y man siya nga direction. Okay? So, your dy. Ato ta sa second, Fy. So, atong Fy, ato siya butang dira nga point, unsa iya mag-create nga moment. This is still clockwise. So, therefore, negative gihapon. And, Fy ta, so, this is your 45 degrees, this is your Fy gihapon. So, opposite over hypotenuse. That is 5 kilonewtons sine of 45. This is your Fy. Multiplied by the moment arm. This is your force y, this is the direction of your force y, and this is your perpendicular distance. Okay? So, pila man na. This is your triangle, so adjacent over hypotenuse, that is 3 cosine of 30 degrees. And this is your dx. So, pila ang atong moment at point O. Your answer here is negative 14.49 kilonewton meter. This has a direction counterclockwise. To make it positive, 14.49 kilonewton meter going clockwise. this is your final answer. And what can you observe sa atong previous nga solution? They are equal. Approximately equal, as you can see, because this is 14.49 and the other one is 14.5. Why? Because during the calculation sa atong di kaganiha, nag-round off ta. And when we round off during sa atong pag-solve and we haven't yet arrived on the final answer, then we can create a discrepancy. But in this case here, wala man ko pang round off dere until sa pag-abot na ko sa final answer, then this is more accurate compared to what I've solved earlier. Understood? So this is how you apply Verignons Theorem. You have to just to solve for the components and to solve for dx and dy for you to solve the moment. And that's just how easy it is. Dili easy, then it's better for you to practice solving this one. Understood? So that is just how the principle of moment works, or the Verignons Theorem. And I hope you can apply this one on our next problems, maybe on our assessments and whatever. If you still are confused on how to do this one, then it is best for you to practice in solving this kind of problems. And maybe you have missed some important points during my lecture. As a summary for this short lesson, we have talked about the Verignons Theorem, and we've been able to solve problems by applying the Verignons Theorem. If you have any questions, please ask me or comment down on the comment section below, and if you have none, then it's good for you. So please don't forget to like, share, and subscribe to this channel. And don't forget to turn on your notification bell. Okay? So anyways, thank you for your time. Thank you for listening to our class, and see you on our next week. Bye.